Hello, and welcome to the first lesson in Module 11, Quadratic Functions. The topic of today's lesson is graphing quadratic functions. So our objectives are, the first, I can analyze graphs of quadratic functions. Our second objective is that I can graph quadratic functions by using key features and tables. And third, I can use graphing calculators to analyze key features of quadratic functions. So today is going to be a vocabulary-heavy day. So first of all, what is a quadratic function? We have been working with these in Module 10. They are an equation of the form y equals ax squared plus bx plus c, okay, where a is not equal to 0, because if a was 0, then you would have a linear equation and not a quadratic one. The leading coefficient is what's going to determine end behavior. What do I mean by that? Well, if it is positive, it's going to open up. If it's negative, it opens down. So whatever that lead coefficient is, your A term, if it's positive, your graph opens up. If it's negative, your graph opens down. A parabola is the graph of a quadratic function. It is U-shaped. So we're going to just put in it's U-shaped. All right, so those are two examples of a quadratic function right there. It's a U, so you have your sides that are going to eventually start to grow very quickly. But it comes to a rounded bottom as opposed to an absolute value graph, which is V-shaped. So there is a distinction between these. This should be a curve as you go through and not coming to a sharp point at the bottom at the vertex. All right, so axis of symmetry. We have talked about this concept before when we were doing some graphing, but it is an imaginary line where the graph reflects. Okay, a point on the left side corresponds with a point on the right side of the axis. So if you have a point that's 3 units to the left, you'll have a corresponding point 3 units to the right of your axis of symmetry. It's a vertical line that is going down the center of your graph. Right? It's through the center of the parabola. It goes through the word we're going to use next, which is vertex, the point of the parabola that lies on the axis of symmetry. Okay, so it lies on the axis of symmetry. This is your either highest or lowest point, which we look at down below here. So vertex, you have either a minimum, which is the lowest point, and the graph opens up, or you have a maximum, which is the highest point, and the graph opens down. So these are the words that we're going to be using often as we do this lesson. Your x-intercepts. We have talked about x-intercepts before. It's where the graph crosses the x-axis. Now, when it comes to quadratics, you can have 0 places where it crosses the x-axis. You could have only 1 place where it touches the x-axis, or you could have 2 places where it touches the x-axis. And we're going to go into more detail with those later on. An important thing to notice here is there are some other vocabulary words that we use for x-intercept. So you can refer to them as roots of an equation or solutions to a quadratic equation. Roots and solutions are both ways that we reference quadratic or the x-intercepts of a quadratic function. Okay? And a y-intercept is where the graph crosses the y-axis. And for this, there will only be one place that you are going to cross the y-axis. All right, so let's take a look at example 1 and 2, which is to identify characteristics. We're being asked to identify the axis of symmetry, the vertex, and the y-intercept of the graph, and then describe its end behavior. So our axis of symmetry, where are we reflecting across? So we're looking for a line that everything is mirrored by, and it's going to go right down here. Okay, so that's your axis of symmetry. So your axis of symmetry is a line, x equals 1. Now your vertex is always going to be either that maximum point or that minimum point, right? It's either the top or the bottom of a parabola. And so here we see it's at the bottom, so it's going to be at -4. So our ordered pair for the vertex is 1, -4. All right, is this a minimum or a maximum? Well, We are opening up, so this is a minimum. It is the lowest that you could potentially be on the graph, right? So this is a minimum. Our x-intercept, where do we cross the x-axis? We cross it right there and right there. So our two ordered pairs, we have -1 and 0, and we have 3, 0. And then lastly, where is our y-intercept? Where do we cross the y-axis? We cross the y-axis right there. The ordered pair of that point is 0, -3. All right. Now, what's our end behavior? As our values get larger or smaller, they both, our x values increase or decrease towards infinity. They are still both going to be increasing in terms of their y values. We are going up forever. All right, so let's look at our second example. Again, let's find our axis of symmetry. So this one, it looks like my axis of symmetry is right down the y-axis. Now, the equation for the y-axis is x equals 0, right? Because it's going to be our 0 point on the x-axis. Our vertex, again, we're looking at that point right here on our y-axis, on our axis of symmetry, and it's our lowest point on the graph, and in this case, it's the origin, so it's just 0, 0. Is this a minimum or a maximum? It is a minimum. It's the lowest point on the graph. It's the minimum. Where is my x-intercept? Okay, my x-intercept is where I touch the x-axis. Well, that's also going to be at my vertex. This is going to be one of those times where your equation is touching the x-axis at only the vertex. That is a special kind, and we're going to do some exploring with that a little bit later on when we start doing some of our other lessons. All right, now our last one, our y-intercept. Where are we crossing the y-axis? That same point, 0, 0, the origin. It is a popular point for this question, but it does check a lot of the boxes for this problem. All right, there are two U-try problems that I would like you to do on your own and then check your work against mine. So our first one, we're going to find our axis of symmetry. And again, my line that divides it in half goes right there. So that is x equals -1 as my axis of symmetry. My vertex, my highest point on the graph, is right up there. That's at -1. So our axis of symmetry always tells us the first coordinate. It's the x value. Okay, so -1, and we're at a y value of 4 on the graph. Is this a minimum or a maximum? This is a maximum. We are opening down, so this is the highest point on that graph, because you see the arrows, we're going to infinity on both sides of it, and they're both decreasing. So -1, 4 is the highest point on this graph. Now, where are my x-intercept? Where do I cross the x-axis? There are two of them for this problem, and I've put points at both of them. So our first one is at -3, 0, and our second point is at 1, 0. And what are my y-intercepts? Where am I crossing my y-axis? It's going to be right here, and that's going to be the point 0, +3. Right? Now let's look at our second example. Again, find our axis of symmetry. Where are we reflecting around? And it's that line right there, which is x equals -1. Now, at the back, you'll remember I talked about the fact that corresponding points on either side are the same distance away. So if we see we've got a point right here and a point right here, and you'll notice they're both one hop away from the line, right? We have a point right here and right here, right? They're both 1, 2, 3 hops from the line. So you can see we have corresponding points on either side that we are equal distance away from the axis of symmetry. All right, so our vertex for this question, where is my vertex at? It is right down here that we know is going to be at -1 to start, and it is -2, that looks like -3.3 and a quarter maybe? Okay, -3.25 would be our point there, because this graph is going, each line is half It is 1/2 and not 1. Thus, you got, the 4 lines to get to 2. All right, so is this a minimum or a maximum? This is a minimum. It is the lowest point on our graph. All right, and now for our x-intercepts, we're going to have to do some approximating. We're going to have to estimate about where they are. So this is a downfall of graphing when it comes to quadratics. So it looks like I have maybe a negative 2.25 comma 0, and that maybe I have a 1.25 and 0. All right, so that's kind of about where we are, it looks like. And where is my y-intercept? It's right there. My y-intercept is at 0, -3. 0, -3. So one of the downfalls on graphing as a method for working with quadratics is unless you have technology supporting you, using a graphing calculator, for example, or using an online graphing program like Desmos, you have to be super precise. And if your roots aren't perfect numbers, it's going to be hard to approximate some of these decimals. And so that is a limitation and a challenge of working with quadratics as a graph. All right. Now, examples 3 and 4, we are going to graph quadratic equations. So there's a couple things that we're going to do first. Our steps that we're going to walk through. We have our equation here, y equals x squared minus 4x plus 1. First thing we want to do is find the axis of symmetry using that equation. So this is the equation to find our axis of symmetry, the opposite of b over 2a. Now this is a component of a formula that we are going to learn later on in this chapter. But for right now, we're only worrying about this part of it, which is where is my axis of symmetry? And so opposite of b over 2a. Notice I'm being very precise in my language that I'm not saying negative b over 2a. I'm saying take the opposite of b. And why do I say that? Because my b value in the case of this problem is -4. So I'm going to take the opposite of -4 over 2 times a. 2 times a is 2 times 1. So what is the opposite of -4? Well, 2 negative signs cancel out. So what's 4 divided by 2? 4 divided by 2 is 2. So that gives me my x-coordinate of the vertex. It gives me my axis of symmetry that I can use to graph my points. Now, our next step tells us find the vertex by substituting the value of x into the equation. So I'm going to substitute in 2 for x in each place of that equation. And I know it's the x-coordinate. All right, so 2 squared is 4. -4 times 2 is -8 plus 1. 4 minus 8 plus 1 is going to give me -3. So my vertex of my problem is at 2, -3. Now we need to determine, is this vertex going to be a minimum or a maximum? And when we look back at the original equation, again, remember we look at the a term. So the a term for this one is 1. Is that positive? Yes, it is. That means this graph is going to open up, and so we have a minimum. Right? 2, -3 is a minimum. It's the lowest point on our graph. So we're going to find our y-intercept by substituting in 0 for x, because we know it's going to be when x is 0. So 0 squared minus 4 times 0 plus 1, our y-intercept is 1. So 0, 1 is one of our points. Now, the next one is make a table of values with the vertex in the center. So oftentimes students ask, well, how do you pick what points we use when we're graphing? And we talked about this when we were doing linear graphs. For this problem, you are going to start, since the vertex is where you mirror from, start at the center with the vertex. So I know I have a point at 2 and -3. That's going to be my center point, because I'm going to work out from there because I can reflect points across the axis. So I know I'm going to go from 2, I'm going to do 3 and 4 going up, so to the right of my axis of symmetry, and then I'm going to do the next 2 points to the left, which would be 1 and 0, right? So the key is we're going to start right there. We know that one already. All right, so now we need to substitute in and find some values. So we just actually found out what the value of 0 was, and it's 1. So now we do 1 squared minus 4 times 1 plus 1, and when you do that math, you get that you have negative 2. And then we do 3 squared, which is 9, minus 4 times 3, so 9 minus 12 is negative 3, plus 1 is negative 2. Huh, that's interesting. 4 squared is 16, minus 16 is 0, plus 1 is 1. It makes sense. My vertex is the center, and everything out from it is going to be balanced. So if I go one step to the left, I'll be at negative 2. If I went one step to the right, I'm at negative 2. 2 steps to the left, I'm at 0. Or sorry, I'm at 1. 2 steps to the right, I'm at 1. So you see how we have this reflection, this balance in these problems. So now we have some points. We have 5 points, which is typically our minimum to graph anything is a minimum of 5 points. All right, so now we can graph our parabola. And so now I know that I have points at 0, negative, or 0, 1. So I'm going to switch to a bigger one. So we have a point at 0, 1. We have a point at 1, negative 2. I have a point at 2, negative 3. 3, negative 2, and 4, 1. Now, can we do one more if we wanted to? What would be 5 squared minus 5 squared is 25 minus 4 times 5 is 20. So 25 minus 20 is 5. And then we add 1 and we get 6. So we could have a point at 6. And let's kind of draw in our our axis of symmetry here, and we're going to just draw it in here as just a light line, right? We know that that's my reflection line. So I don't even have to calculate what negative 1 would be. I know that it's going to be at 6 because I have to be at 6 for it to be balanced. So here is my quadratic. And do your best for connecting the dots. It should look like a U shape, right? So it should not have a sharp point like that at all, right? It should be U-shaped, a gentle curve throughout the whole thing. Okay, I do expect it to be drawn to the edge of the grid. I do expect you to have your arrows at the end showing me what direction it's going in. So you are expected to have those. All right, let's look at our second problem. We're going to zoom in on just the formula and the table first, and then we'll go to the graph side. So the axis of symmetry, remember it's the opposite of B over 2A. So the opposite of B would be negative 12 over 2 times 3. So negative 12 over 6. What's negative 12 divided by 6? It's negative 2. So I know my vertex starts at negative 2. So now I substitute that in. So we do negative 2 squared is 4 times 3 is 12. And then the plus 12 times negative 2 is negative 24. So 12 minus 24 plus 5 gives me negative 7. Is this a minimum or a maximum? I am a positive A term, so it's a minimum. And then what's my y-intercept? When I substitute in 0 for my x value, well, the whole first two terms goes away because anything times 0 is 0. So we just are left with 5. So our y-intercept is at 0, 5. So take our vertex. That's our center value. So we have negative 2 and negative 7. All right, so now we need to work our way around it. And I'm going to go to the right because I already know if we put in negative 1 and 0 and negative 3 and negative 4, right? These are our values that are on either side immediately adjacent to our axis of symmetry. But I already know one of my points is 0, 5, which means I know negative 4 has to be at 5. right? Because it's mirrored, it's reflecting across. Now you can go ahead and please type this into your calculator, but be careful when you type in -4 squared, that -4 has to be in parentheses and then square it so that you're squaring the negative sign as well. All right, so now let's look at -1. So -1 squared is 1 times 3 is 3. 12 times -1 is -12. So 3 minus 12, that's -9, plus 5 is -4. And if we did the math with 3 as well, we would get the same thing. Right? We'd have 27 minus 36 plus 5. So those are my points. Now I'm going to go ahead and graph them. So I go ahead and I'm going to start at my vertex. I'm going to do -2 and -7 to start with. And then I'm going to go to the right first. So we have -1, -4. So we have a point right there. We have a point at 0 and 5, which would be right there. Now remember, we had an axis of symmetry here. So one kind of cheat method that you can use with the axis of symmetry is you would graph points on one side of it. And if we put in 1 here, 3 plus 12 plus 5, we're going to be well off this grid, so we can't go beyond it. But we can use this, and I know that that +4 point down at -1, -4, well, it's also going to be right across the axis of symmetry too. And I know this one, it's 2 units to the right, so I need to go 2 units to the left. Right, so we can see this symmetry, and we can save ourselves a little bit of time when it comes to calculating and finding points. So now we're going to draw in our curve, and that wasn't a great one on my part, but here we go. So we've got our curve drawn in. I'll erase the part that wasn't great, and there we go. We have our graph. All right. So we have now some U-try problems. And you're going to go ahead and do those on your own. So we have one U-try problem. So let's start off with our axis of symmetry. So we have the opposite of B. So opposite of +4 is -4 over 2 times A, which is -2. And so we get -4 over -4, which is 1. So our vertex starts at 1. And we're going to substitute in, and we do 1 squared is 1, times -2 is -2. 4 times 1 is 4. So -2 plus 4 is 2, minus 3 is -1. So that's my point here that we're starting with, 1, -1. That's my vertex. All right. Is this a minimum or a maximum? I look back at my A term. My A term is negative, so this is a maximum. This is your highest point on the graph. What's my y-intercept? I substitute in 0. -2 times 0 squared goes away. 4 times 0 goes away. My y-intercept is at 0, -3. All right, so let's look at our points. We've got, we're going to go for our points on either side, and we're going to say 2 and 3 and 0 and -1. All right, I already know, though, 0 is -3. That's one of my points that I already know. So that means I can already intuitively say that 2 is going to be -3. And we can double check it. 2 squared is 4 times -2 is -8. 4 times 4, or sorry, 4 times 2 is 8, so -8 plus 8 is 0, minus 3 is -3. So now we do the next one. 3 squared is 9 times -2 is -18, plus 3 times, 3 times 4, and then minus 3, and you are going to get -9. All right, and I know based on my reflection properties that -1 will also be -9. We can do the math on it though. -1 squared is 1 times -2 is -2. Negative 1 times 4 is negative 4. So negative 2 minus 4 minus 3 gives me negative 9. All right, so let's graph our points. We're going to start with what is my vertex. My vertex is at 1, negative 1, so that's right there. And then I'm going to work my points to the right. So 2, negative 3, so that's a point right there. 3, negative 9 is a point right there. 0, negative 3, my y-intercept is right there. And negative 1, negative 9 is down there. And so we go ahead and we draw in our graph, and we put arrows at the ends of it. All right, so let's take a look at the next one where we are calculating features of parabolas. So now I'm not giving it to you. We need to calculate it and figure it out ourselves. So the axis of symmetry, the opposite of b over 2a. We've got the opposite of negative 8 is positive 8 over 2 times negative 2. And that is 8 over negative 4. 8 over negative 4 is going to equal negative 2. All right, so our vertex is going to be at negative 2, and we need to substitute negative 2 in. So negative 2 squared, negative 2 times negative 2 squared minus 8 times negative 2 plus 2. When you do all that math, you get negative 210 as your vertex. Based on what we know, is this a maximum or a minimum? Our A value is negative, so that means we're opening down, so this is a maximum. It's the highest point we're going to be. Our y-intercept, we're going to substitute in 0. So negative 2 times 0 squared goes away. Negative 8 times 0 goes away. All we're left with is a positive 2. So we have 0, positive 2. Okay? All right. Let's take a look at letter B. We have 2x squared plus 4x plus 6. So our axis of symmetry, the opposite of B. So we have negative 4 over 2 times A, 2 times 2. So negative 4 over 4 is negative 1. When I substitute that in for my vertex, we have negative 1. So negative 1 squared is 1, times 2 is 2, 4 times negative 1 is negative 4, plus 6, we get a y value of 4. Now, my A term is a positive 2, so this is going to be a minimum because we are opening up. And lastly, my y-intercept, if we substitute in 0 for x, first two terms go away because we're multiplying by 0, and we find that it is 6. So when you're in standard form, your C value is your y-intercept. As you look at it, your C value will be your y-intercept. All right. So let's take a look at letters C and D now. These are you try problems. I want you to try them on your own and then check your work against mine. Letter C, we have y equals x squared plus 6x minus 6. So we start off with find the axis of symmetry. The opposite of 6 is negative 6 over 2 times 1. So we have negative 6 over 2, which is negative 3. My vertex starts at negative 3. We do negative 3 squared, that's 9, plus 6 times negative 3, negative 18. 9 plus negative 18 is 9 plus negative 18 is negative 9. And then when we minus 6, we subtract 6 from it is negative 15. So we have minus 15 as our y value. We are opening up. So this is a minimum, right? Our A term is positive. It's a positive 1. And we substitute in 0 for x. And we get that our y-intercept is at negative 6, because that's all that survives multiplying by 0. All right, letter D. We have y equals negative 3x squared minus 12x minus 2. Opposite of B, positive 12 over 2 times A, negative 3. So 12 over negative 6 is going to give me negative 2. And we are going to substitute that in. Negative 2, so we do negative 3 times negative 2 squared, minus 12 times negative 2, minus 2. And when we do all of that, we get 10. All right, is this a minimum or a maximum? Our first term is negative, right? It is a negative sign, so this is a maximum. We're opening down, we have a high point. And lastly, my y-intercept, we substitute in 0 for x. First two terms go away. We have 0, negative 2 as our values. All right, we're going to go to our last page for the notes for today, and we're going to use some applications. So we have an acorn dropped off of a tree branch 70 feet above the ground. The function h equals negative 16t squared plus 70 gives the height of the acorn in feet after t seconds. What is the graph of this function? About what time does the acorn hit the ground? All right, first off, this is our falling object model. This is for an object falling on Earth. We've talked about Newton's laws in science class, so you have heard of the concept of acceleration and the fact that acceleration is based on gravity, and gravity is different on different planets and different planetary bodies. So on Earth, the force due to gravity in feet per second squared is negative 16. Negative 16 feet per second squared is the acceleration due to gravity. In science class, we use the metric system, and it's negative 9.81. So that's just the difference between the two measuring systems. So how are we going to go about doing this? Well, we can find a vertex. We could do that. We could find the y-intercept. I'll tell you right now, the y-intercept is your vertex, and it's going to be at 70. So we can just go ahead and put that first point at 0, 70, because we know that's where it's going to be, because that's our starting height right there. So let's figure this out, though. So we know the first one is at 0 feet. Okay, let's look at what can we do with our equation. Well, we can just substitute in a couple different times here. So we could do negative 16 times 1, so after 1 second squared, plus 70. All right, so what does that have when we do that? So h is going to be equal to, that's an h, doesn't want to connect. So 1 squared is 1, so we have negative 16 plus 70. So we have a height of, for our first point, is at 54. Okay, that's our first point that we can graph, so we'll do that. Let's do that. So we have 54, so that's approximately here, so it's a little bit below the 55 line, but it is, above 50. All right, well, let's try 2. So let's find the height of 2. So we've got h equals negative 16 times 2 squared plus 70. Negative 16 times 4 is negative 64 plus 70. And when I add those together, negative 64 plus 70 is 6 feet. So our second point is going to go at 2 and 6, so we're just above that line there. And then our third point, we'll do it in green. H is going to be equal to negative 16 times 3 squared plus 70. So negative 16 times 9 is negative 144 plus 70. Okay. And that is equal to negative 74. Well, we can't graph that. So we are going to connect these dots, though, and we're going to make a curve. And we really don't need the arrow on the end, because are we going to an infinity here? No, we're not. Because when that acorn hits the ground, it's not going through the ground. This isn't some sort of acorn torpedo or drill or anything that's going to go to within the earth 74 feet. That's not going to happen. So we know it's going to hit somewhere between 2 and 3 seconds. So the question is, uh, about what time does the acorn hit the ground? The answer is 2 to 3 seconds. So I just need that approximation. Just tell me between what two values is it going to hit the ground? All right, let's look at letter B. We have a child dropping a pebble from a height of 30 feet above a lake. The function h equals negative 16t squared plus 30 gives us the height of the pebble in feet after t seconds. Graph the quadratic function, and then about what time does the pebble hit the water? All right, so we're going to take the same approach that we did on the last one. I'm going to actually do the first point for us, right? So we've got h equals, and we'll just prove it mathematically, 16 times 0 squared plus 30. And so that's going to be h equals 30. So our first point is right there at 30. Let me get a bigger point. There we go. All right. So our second point, h equals negative 16 times 1 squared plus 30. Well, that's going to be negative 16 plus 30, which is 14. So if I move over, we're going to go just a little bit below that line. So it's going to be right about there. And then let's calculate our third point. We've got h equals negative 16 times 2 squared plus 30. So 2 squared is 4. 4 times negative 16 is negative 64. And negative 64 plus 30 is negative 34. So we know we're going to be below the ground. And so when we go ahead and we put in our graph, it's going to look something like that. And so our answer for this one, about what time does it hit the water? 1 to 2 seconds. So it'll fall 1 to 2 seconds before it hits the water. Now, in this case, you could have some sort of a negative elevation because we're taking, h is the height above the water. So you could end up with a negative value for height on this. We don't know the depth of this lake. But once it hits the water, it would be moving at a different rate of speed than it is through air. So it wouldn't be the negative 16 anymore. But anyways, so that's the notes for today. If you have any questions, please bring them to class tomorrow. Otherwise, I hope you have a great day.